Hello everyone, this is John Saida from Section C. Today is my topic about chemical analysis of water. Let us know about it. This is the topics of introduction, abstraction, types, types of water, chemical analysis of water, quality assurance of project plan, sampling and sample treatment, sample preservation, pre-treatment. Let us know about introduction. Water is an essential resource for all living species, including man, and it's necessary to analyze a range of natural water. Example: seawater, rainwater, surface water, and groundwater. Polluted water, etc. Industrial water and sewage water. And purified water is example potable water and distilled water. This article presents an overall sample and sample treatment procedure and discusses a range of analytical techniques used for the qualification of major, minor, and trace constituent. Abstraction. The following is a proposal for revision of method, performance, characteristics for the chemical analysis of water intended for human consumption under Drinking Water Directive (DVD). According to the proposal, the EN ISO IEE 17025 standard should be introduced in directive, and the performance characteristics measurements uncertainty MU and the limit of qualification LFQ should be replaced or complement those current in use. As example, crudeness, precision, and limit detection. Minimum performance characteristics of MU and LOQ are suggested for each chemical parameter. The types of water. Environment water. Sample of water from the natural environment are routinely taken and analyzed as part of predetermined monitoring programs by regulatory authorities to ensure that the water remain unpolluted, or if polluted, that the levels of polluted are increasing or are falling in line with an agreed remediation plan. An example of such scheme is urbanized monitoring scheme operated on all the major river systems in the UK. The parameter analyzed will be monitored scheme operated on all the major river system polluting source in the area. The next one is drinking water supply. Surface or groundwater abstraction from the supply of drinking water must be capable for meeting rigorous chemical standards following treatment. This requires a detailed knowledge of water entering the treatment plant in addition to the normal soot and environment chemical parameter. Other parameters such as hardness, phenol, oil, and in other some cases as real-time organic profile of incoming water as in river deregulation scheme. Industrial process water. Industrial process water, the control of quality of process water can be critical to the quality of the end product. Water is often used as carrier of reagent, and the loss of reagent product must be continuously monitored to ensure the correct replacement rate. Parameter measured related especially to the process in use and to any expert contaminant to that arise by product. This may include unwanted organic chemical appearing in an organic chemical process through contamination with oils and grease from machinery. In this application monitoring scheme analyzes for all possible Uh, Possible contaminant arising within the application monitoring scheme. The process of an additional contaminant that may have particularly adverse impact of environment such as cyanide and many organic species such as pesticides. In the nuclear industry, analyzers focus on specific isotopes or elements are interested, where the nuclear industry makes wastewater discharge to rivers which have drinking water abstraction on them. Radioisotopes which could potentially be harmful or those with long half-lives such as titanium will form part of routine monitoring suite. Chemical analysis of water. Chemical analysis of water considerable Chemical analysis of water provides considerable insight into the health and working of lakes, rivers, oceans, and groundwater. Water chemistry has helped the scientists to define the different current and circulation of the world oceans, improved their understanding of water interaction with earth geologic material, and given insight into the impact human activities on water bodies. It has also provided a clear understanding of limits of water body ability to assimilate taking some level of pollution without harming in the water system in aquatic plants and animals and human who may be used water. Discrete analyzer is increased applied for practical chemical analysis of water. The analyzer facility then speed up sample processing and reagent handling. Continuous loading of samples increases the efficiency, cooled reagent storage, and the large derivative allow increase through the samples. Quality assurance of project plan. Water monitoring and the chemical analysis of water requires careful planning achievement valid result. The most important step in another monitoring program is the development of a plan known as Quality Assurance Project Plan QAPP. To bring into the focus the purpose of water monitoring efforts, the currently known information about the water bodies and the intense use of resulting data. Data may be used for such varied purposes as the educational course requirement, contribution to a statewide database, or even in a lawsuit. Once this information is known, project manager establish specific parameters to be measured, uh, set in a level of quality assurance needed to support the intent data use and determine the data steps of monitoring program. Sampling and sample treatment. The collection of water samples and subsequent samples treatment depend primarily on the chemical of water collected and aim of the analysis. It is important that samples are collected in such a way that they are respective of the water bodies from which they are taken. This means that the concentration of the determinant and interference in the sample should be not for the concentration present in original water bodies. The need of a representative may be limit of volume and simple may be collected simple volumes taken with disturbing an original gradient. Sample integrity, also known as surfaction, has occurred. Analysis of samples that have been taken as sort properly is useless. Result of such analysis may be leads to false that the nearest conclusion following inspection of result. Sample preservation. Ideally, samples should be analyzed in situ or on the site on sampling the field. If direct measurements are not possible or are too expensive, samples should be analyzed as soon possible to avoid the need of preservation. However, samples cannot always be analyzed directly and they may be stored for long preservation necessary. The preservation of water samples is covered is ISO Indian standard and identified the preservation methods described in this standard specification of container material, preservation of exposure, light, temperature control, 2 to 5 degrees, pH control, addition of sulfuric, nitric, and phosphoric or sodium hydroxide, and hydrolysis components and complexes and measured of reducing quality components and surfaction effects. Pretreatment. Depending on the planned using of conclusion, pretreatment of sample may be necessary as initially suspended in the sample enlargement and suspended matter particles smaller than 0.45 mm can pass through the filter at treated with the dissolved matter. These tiny particles may contain the greatest part of the trace constituent owing to their high adsorptivity and large surface area. Processing have may be designed to the correct for the contributions made by small particles to the true dissolved content. The chance of contamination of small during pretreatment are lower than laboratory. Pretreatment in the field requires some experience when the samples cannot be filtered in the field. This should be filtered generally causes contamination of sample and increasing of variability of the analytic result. Conclusion. The WQ for the river as the whole was 7.4 on the rating scale percentage. The QB of the each test of the multiplied by the weighing factor which very depends on the importance of each test. Result values from the each test are added together obtained by the water quantity index. Thank you.